My name is Gustavo Reyes Baez. I'm from Biomedical Engineering. I'm presenting the Phase C2 with my partner Jose Francisco Abrams, which we will be talking about how to develop a smart cane. The outline of this presentation will be the system integration plan, manufacturing and integration plan and procedure, which will be drawing the entire system operation plan, the user manual, and the performance estimates for the last system, budget, and project planning of the next phases. The system integration plan. On the first plan, you can observe the figure 1, all interaction with the handle and the hand of the patient. We can observe how to determine all the variables known as the tensile strength, the cane, the weight of the handle, the weight of the housing, the radius of the cane, the cross-sectional area of the cane, the heat that can be absorbed of the material, the 3D printer that will be a PLA material, as an adjustable size and handle dimension to get the correct comfort to the patient. The unknown variables that we can need that are needed to find and calculate where the grip breathe inside the width and the length, that is the inside of the hand, that will be the fitness of the hand for the handle, the location sensor, which are the vibrator that are the alert for the patient if they are in risk, and the torque. All the variables are known in the table 1 that will be on the right of the presentation. For the second integration plan, you can observe in the figure 2 all the interaction with the handle and the housing with components of all control system integrated with the structural design. We determine all the variables known as the quantity of components, the angular position of the ultrasonic sensor, the motor vibrator frequency, the sound power by the buzzer, the force of the trigger, the power signal, the operation time, and hand dimensions. The unknown variables that we need to find and calculate were the component housing locations, the housing leads dimensions, power and electrical components weight. All the variables as the other presentation are in the table 2 on the right of the presentation. On the manufacturing and integration, the assembly plan and procedure, the figure on the right is the system component describer system of the engineering, which is the subsystem 1 of control system that are the electrical components is identified by the red balloon indicating all the electrical components. For the subsystem 2 of the structural design, we can identify by the blue balloons. This is an exploded view of the procedures of all materials of this experiment. The acquired components that are not manufactured by us are the vibrator motors, the ultrasonic sensor, the mini breadboard, the Arduino, the buzzer, the battery, the jumper cables. All the dimensions and weight were in the consideration for our structural design. The vibrator and sensor in the manufacturing steps on the manufacturing and assembly plan. On the figure 4 on the right, you can see the components interacting with the location of the cap. The component in this figure is considered by the cap 2 vibrators, sensors, and ultrasonic sensor. The manufactured tools are the cap for the handle, which is in the handle grip, which is integrated with a vibrator, and the comfortable for the patient, which they cannot see the sensors. For the manufacturing process, is described in 3 steps. It describes dimensions, in location marks, and close. On the dimension, we can see that we selected the measuring tool, check all the dimension of handle grip and hand dimension. On the location tool, that will be the second step, make a specific placement for the screws for fit all the sensors of the cap and the handle grip, and apply it carefully just in placement, just in case you cannot cut yourself or get in danger other person. And close is compress all the components into the housing and the handle grip. And on the right will be the cap with the ultrasonic sensor and the handle grip on the right, which is not manufactured yet. The manufacturing process of the coding interface is described in 3 step 2. That will be the software, the coding, and the system execution. On the software, that will be the first step. You need to install the MATLAB software in the computer that is going to be used to code and install the Arduino. The coding That is the second step, is access the student account demo lab software, which is a free student version on the Polytechnic University, log the required code and create the field with the smart key requirements, and test, corroborate, and save the field into the Arduino system. The system execution means to follow all the procedures on how to install all the components of the control system with a circuit and assembly and activated the device. For the sequence schematic, we can see all the diagrams of how we will be developed, connect all the components to perform each function, and can deliver the best efficiency to the patient and don't have any troubleshooting and any problems to the patient. The manufacturing process of the simulation was developed in a web called Tinkercad. Tinkercad has the same specification maybe as the first the other diagram manufacturing. There will be software test and system result that will be entering on the web of the Tinkercad software. That will be a free web version app in the computer that is going to be used to simulate the sequence assembly of all electrical components. On test, that would be the second part. Access the free web account in Tinkercad software, log the required 3D electrical design, and create the field with the smart key requirement. At the same, test, corroborate, and save the circuit assembly and the system result. Follow the procedure on how to install all the components of control system with the system assembly diagram to test and the device. All the controller system is consisted by the mini breadboard, the Arduino, the LED light, the buzzer, the battery, 9 volts, the jumper cables that will be helping you to connect all the mini breadboards Arduino. All the connection will be with the jumper cables, the ultrasonic sensor, and the vibrator motors. On the structural handle grip was developed with the design that will be able to get the best feeling as an ergonomic and cylindrical shape for the comfort of the hand patient. It's designed with an average hand dimension to fit equally in every hand for any patient, each woman or a man or younger people, they can use it. The manufacturing step was developed in 3 steps as the other manufacturing step, that will be print, aftercare, and coating material. The first step was importing the CAD drawings from Creo to or SolidWorks to a software prepared for a printed like Meshmaker or Prusa. We use those two in the Polytechnics. We're gonna use it. Confirm measurements, especially thickness and if needed support for drawing. The printer on the Prusa E3 MK2 3D printer at the biomedical engineering facility at the rehabilitation laboratory at the Polytechnic University, that we don't have any cost to our permanent students. On the aftercare, we can make sure to use a sandpaper or Dremel, that will be the figure on the right, until all extra fibers are clean. This will help to get it a beautiful 3D printer material that will be a little bit more consistent and more comfortable for the patient. Check all the dimensions if they are correctly printed. And for last, that this will be a material for people that they want to look it good and very special for them. Apply coating for high quality use, that will be a material to the customer or patient. For the housing components, all the electrical components were dated in the best dimension to develop the smallest and fittable housing case for the patient, and has a lightness smart key. The manufacturing step was developed in 3 steps: print, aftercare, and coating material, importing the CAD from Creo, SolidWorks, or other software to prepare the printer, naming Meshmaker or Prusa, confirm measurements, especially thickness, and if needed, support the drawings. Use the Prusa printer at the biomedical engineering department facilities at rehabilitation laboratory of Polytechnic University, which has no cost for permanent students. Make sure to use a sandpaper or Dremel scrub until the extra fibers are clean. Check all the dimensions if they are correctly printed, and apply the coating for a high quality use. This is the final part using the PLA material. for the housing lead, it is the same dimension and manufacture process as the housing components. You can observe all the dimension correctly in the ANSI standard. The manufacturing step was developed in the three-step that we have been using for the all process of manufacturing a 3D printer. So we print after current coding material. We need to import the CAD of Creo to the software Mesh or Prusa. Confirm measurement, especially the thickness of the design. Then print it on the 3D printer of the biomedical facilities in the Polytechnic, which has no cost. Make sure to use a sandpaper or a Dremel to scrub all the extra fibers that are to get clean, and apply the coating material for high quality uses that will be for the patient, and we are gonna use it. On the assembled housing, we can observe a concept of how the components of the housing case will be closed with all components in the right place, indicating the ultrasonic sensor for detect obstacles in a location with an angle of 45 degrees next to a LED light, which will be indicating that the system will be turning on and turning off. For the last part that I'm gonna be presenting, this is the drawing system, which consists of the final assignment completed as the BOM view with all components of control system. For the next topics of system operation plan, performance estimates, system budget, and project planning, my partner Jose Abrams will be presenting. So thank you for all your attention.